Good evening, my dear student. Myself, Dr Apil Sir. Here I am going to discuss about the eigenvalue, eigenvectors of a matrix. Okay, and basically here I will discuss some basic or important properties which are related to eigenvectors as well as eigenvalues. Okay, hope this video will be helpful for you. Okay, so guys, already we have discussed about the eigenvalue and eigenvectors in the previous lecture, and here basically just I will discuss about the some basic properties of eigenvalues. Okay, so guys, what is eigenvalues or eigenvectors? Yes, so you see here, suppose we consider a matrix. A is a matrix, and suppose this matrix is here a square matrix. Yes, a square matrix. Then A minus of lambda I, this is also will be matrix for scalar lambda. एक स्केलर क्या है, लैम्डा क्या है, स्केलर है. A minus lambda I will be a matrix. Yes, this I is nothing, identity matrix. I is nothing, identity matrix. Yes, so obviously this will be a matrix. Now guys, so since this is a matrix and A is our square matrix, that means A is our square matrix, I is our square matrix, that means lambda I also have a square matrix. Yes, that means A minus of this one will be a square matrix. That means this is will be a square matrix. And also we know that for any square matrix we can associate a number, or for any square matrix we can easily find the determinant. So since this is a matrix, a square matrix, that means determinant will be exist, A minus lambda I. So this determinant we can easily find. Yes, this determinant also we can easily find. Now you see here, just I will take an example first. After that I will go to this concept. Yes, just I will take a basic 2 by 2 matrix. Suppose A is our here 2 0 1 1. So this is the matrix. Then what will be I here? I will be 1 0 0 1, because you think here A is nothing 2 by 2 matrix or a square matrix of order 2. So definitely you need to take here I is also is a 2 by 2 matrix. Otherwise this addition will not exist. Yes, so this addition will not exist. So now you see, this is our I, this is our S. Then what will be our lambda I, guys? Yes, what will be lambda I? So here lambda I will be lambda 0 0 lambda. Yes, this will be, just you take the product of this lambda with all the elements of this I, so you will get this one. Now if we want to find this one, A minus of lambda I, A minus of lambda I, then what will be the matrix? 2 minus of this one. That means that you need to subtract from the corresponding elements here. So 2 minus lambda will be there, 2 minus lambda, 0 minus 0 will be there. Yes, 1 minus 0 will be there, so here 1 will be there, 1 minus lambda, that means here will be 1 minus lambda. So you see here A minus lambda I also is a square matrix, and since this is a square matrix, so we can easily find the determinant. So what will be the determinant of this A minus of lambda I? This will be here 2 minus of lambda 0 1 1 minus of lambda. So if we take the determinant of this one, what will be the determinant of this one? If we take the product of this one, इसका साथ इसको product ले लो, this will be 1 minus of lambda and this will be 0, 1 into 0. So that means here will be 2 into 2 twice of lambda minus lambda plus of lambda square. That means you will get here lambda square minus of 3 lambda plus of 2. So this will be the value of this determinant. Now you see here, we consider here A is a 2 by 2 matrix, a square matrix we have considered, and finally what happened here, you see determinant of A minus lambda I is a matrix, is a determinant or is a value or expression, you see. But you see here, this expression is nothing, is a polynomial in lambda. This is a polynomial is lambda. Yes, polynomial, I hope all of you know this type of numbers. Yes, a n x to the power n, a n minus 1 x to the power n minus 1. Yes, this one. So this is a polynomial. So this is also is a polynomial in lambda. Here x में था, इसमें lambda में. That means क्या होता है, for any square matrix A minus lambda I will be a square matrix, and determinant of this A minus lambda I will always be a polynomial in lambda. And guys, this polynomial or this polynomial, yes, these are same thing. This polynomial is called characteristic polynomial. This polynomial means this one, A minus of lambda I, determinant of A minus lambda I. This is a polynomial, and this polynomial is called here, guys, this is the characteristic polynomial of which of this matrix capital A matrix का characteristic polynomial. So guys, characteristic polynomial of a matrix is nothing, simply you find A minus of lambda I and you take the determinant of this matrix. That determinant will be an expression or polynomial in lambda, and that is called the characteristic polynomial of this lambda. Now, since this is a polynomial, and if we put equal to 0, then this will be an equation. This will be an equation. So A minus of lambda I, this is our polynomial, and if you put here this one equal to 0, then this value is called here characteristic equation, or this equation is called here characteristic equation. So this will be the characteristic equation here for this case, 3 of lambda plus 2 equal to 0. So this will be the characteristic equation of क्या है, this will be the characteristic equation of this A. So guys, hope this characteristic equation and polynomials are very basic thing. Hope you have no doubt on this characteristic polynomial as well as the characteristic equation. Okay, now you see, since this is our equation, so we can solve this equation. So if you solve this equation, yes guys, so this one, lambda square of 3 lambda plus 2 will be 0. So if we simplify this one, this will be this one, huh? So from this on, the lambda will be 2 and 1. So this lambda equal to 2 and 1, these are nothing, these are the solution of this characteristic equation, and this solution is called here eigenvalues. Yes, this solution is called eigenvalues of this matrix capital A. So guys, basically what happened here, characteristic polynomial, characteristic equation and characteristic roots, yes, ये तीनों में रिलेशन है. जैसे कैरेक्टरिस्टिक पॉलिनोमियल क्या है, a माइनस लैम्डा आई का डिटर्मिनेंट ले लो, दैट विल बी कैरेक्टरिस्टिक पॉलिनोमियल. नाउ दैट पॉलिनोमियल, दैट मीन्स a माइनस लैम्डा आई का जो डिटर्मिनेंट है, इफ यू पुट दैट ऑन इक्वल टू 0, दैट विल बी एन इक्वेशन, एंड दैट इक्वेशन इज कॉल्ड हियर कैरेक्टरिस्टिक इक्वेशन. And if you solve that equation, you will get some zeros or roots. That roots are called the eigenvalue of the matrix A. Okay, so hope the eigenvalue, characteristic equation और characteristic polynomial में किसी का डाउट नहीं है. So already देखो ये characteristic roots और zeros और eigenvalues already बता दिया. So हमने जो matrix लिया था इसमें 2 0 1. So this is our matrix था. Yes. So this is the eigenvalue of this matrix क्या होगा, eigenvalues will be here 2 and 1. So these are the eigenvalues. So hope all of you can find the eigenvalues, eigenvector and characteristic polynomial. Yes. So hope all of you can find easily the eigen vectors. Sorry. So hope all of you can easily find the characteristic polynomial, characteristic equation as well as the eigenvalues of a matrix. Okay. So now here you see some basic properties are there. Yes, you see. First of all, you see this definition. Sum of the principal diagonal elements of a matrix is called trace. कोई भी एक मैट्रिक्स ले लो, this is our matrix, then this is are called the principal diagonal. Hope all of you know this one. And this sum of the all these elements are called the trace of this matrix. Yes, and here you see on important properties is there. Sum of the eigenvalues of the matrix is equal to the trace. ये trace को sum का trace का value and sum of the all the eigenvector values are always equal. So for example, you see here for this question here, you see for this matrix, what will be the trace here? Yes, trace will be here 2 plus 1, so that means 3. And also you see sum of eigenvectors कितना है? Sorry, sum of eigenvalues कितना होगा? 1 plus 2. So this is also 3. Yes. So you see trace and the sum of the eigenvalues are always equal. So this is an important properties. You must remember these properties. Now you see the second properties here. Suppose lambda 1, lambda 2, lambda m are the eigenvalues of a matrix A of order n. Suppose yes, A का कितना ऑर्डर है? ऑर्डर m है, m ऑर्डर है और जिसका आइगन वेक्टर्स क्या है? a1 a2 अप टू am है. Then आइगन वेक्टर्स ऑफ द then eigen value of a to the power n will be lambda on power n. Yes, a to the power m. Yes, sorry. So guys, you see another important properties is also there. Suppose lambda 1, lambda 2, lambda n are the eigenvalues of a matrix A of order कितना है? Suppose order is n square matrix. Then the eigenvectors, then the eigenvalue of a to the power m. Then the eigenvalue of a to the power m will be lambda to the power m, lambda to the power m, lambda 3 to the power m, lambda n to the power m. Yes, that means you see here in our example, suppose this is the matrix 1, this is our matrix. So here eigenvalues क्या था? 2 and 1 था. Then what will be the eigenvalues of for a square? A square का eigenvalues क्या होगा? 2 square and कितना होगा? 1 square. That means 4 and 1. So once find the eigenvalue of any matrix A, then we can easily find the eigenvectors for a square, a cube, a to the power 4. Yes, all the matrix for all the power integral power of the matrix, we can easily find the eigenvectors. Yes, so this is an important. And you see the eigenvalues of Ka are k of lambda 1, k of lambda 2, k of lambda 3, k of lambda of n. That means for this matrix, you see, for this A matrix, yes, for this A matrix, what will be the eigenvalues for twice of A? What will be the eigenvalues of this twice A matrix? Then eigenvectors of the twice A matrix will be 2 into 2 and 2 into 1. देखो just eigenvectors का साथ हमने 2 को मल्टीपल करते, that means this will be 4 and 1. Sorry, 4 and 2. Yes, 2 into 2 मतलब 2. So the eigenvectors of 2a, 3a, 4a, 5a we can easily find by using these properties. Okay, and also you see there are many properties are there. This is also another properties. eigenvalue of A inverse. Suppose A is a matrix and which is invertible. That means we can find we can find the inverse of a matrix. Then if lambda 1, lambda 2 up to lambda n are the eigenvalues of this matrix, then this will be happened. Yes. And another properties is also there, a product of the eigenvalues is equal to the determinant of the matrix A. That means suppose here we see 2 0 1 1. This is our matrix, and what is the eigenvalues here? Eigenvalues are here 2 and 1. So if you find the product, 2 into 1, this will be 2. Yes, this is the product of the eigenvalues, and this will be equal to the determinant of this one. So now you find the determinant of this one. You see 2 0 1 1. So if we take here 2 into 1 minus 2 into 1 minus 0 into 1, so this will also 1 2 here. So you see the determinant of the matrix is nothing equal to the product of the eigenvalues. So this is also an important properties you must remember. Suppose sometime what happen, they provide the eigenvalues only. Yes, then from that information we need to find the determinant of that matrix. So we can easily find. Okay, so you can easily find. Now you see here another properties also is there. If A and P are square matrix and also P is invertible. Yes, suppose मान लो A क्या है, some square matrix है and P is also is a square and this P is invertible. That means P inverse is exist. Then what happen? This A and this P inverse AP will have same eigenvectors, as well as their determinant also will be equal. Yes, do you know the determinant of this A and determinant of P inverse AP also will be here equal. These two will be equal, and in this case here you see if A and P are square matrix of same order, as well as the inverse of P is exist, that means P is invertible, then these two matrices will have same eigenvalues. So you must remember these properties. And you see here, if A and B are square matrix as well as they are invertible, that means A inverse and B inverse exist, then what happen guys, this AB matrix and BA matrix, they have same eigenvalues. Okay, and also you see if A is singular, you see if say A is singular, then what happen, at least 1 0 will be the eigenvalues, or at least one eigenvalue of that matrix A will be 0. That means क्या है, देखो कोई भी एक मैट्रिक्स का आइगन वैल्यू 0 होने से वो हमेशा क्या होगा, नॉन सिंगुलर होगा, और नॉन सिंगुलर होने से वो क्या होगा, उसमें एटलीस्ट एक तो ऐसा आइगन वैल्यूज मिलेगा जिसका वैल्यू 0 होगा. दैट मीन्स यू सी फ्रॉम दिस वन, अभी जो प्रॉपर्टीज दिया था, सपोज मान लो कोई भी एक मैट्रिक्स में 0 एक क्या है, 0 एक आइगन वैल्यू से, तो अभी मालूम है हम लोगों को जो डिटर्मिनेंट ऑफ ए क्या होता है, प्रोडक्ट ऑफ आइगन वैल्यूज, प्रोडक्ट ऑफ आइगन्स होता है. तो जब एक कोई भी एक वैल्यूज 0 होने से तो पूरा प्रोडक्ट क्या होगा, 0 हो जाएगा. दैट मीन्स द डिटर्मिनेंट ऑफ दिस ए विल बी 0 एंड देन डिटर्मिनेंट ऑफ ए इक्वल टू 0 होने से द मैट्रिक्स विल बी सिंगुलर. सो दैट मीन्स व्हाट हैपन, इफ वन आइगन वैल्यूज इज 0 देन the matrix will be will be singular. Okay, and also you see eigenvalue of a triangular matrix are just diagonal elements, are the diagonal elements only. This is for example, I hope all of you know the triangular matrix, upper triangular matrix, lower triangular matrix. Yes, you see this is the principal diagonal, and if all the elements which are just below diagonals are 0, all the elements which are the below diagonal or below the principal diagonals are 0, then this is called upper triangular. Is upper triangular. Or this type of matrix, suppose a square matrix है, yes, but all the upper diagonal, all the elements which are just above the क्या है principal diagonals are 0, then this is called lower triangular matrix. Then in case of upper triangular or lower triangular, the diagonal principal diagonal elements are here the क्या है भाई eigenvalues of the matrix. Yes, suppose if we consider this matrix, suppose 1 0 0 1 3 0, yes, 0 3 1. So this is clearly, this is क्या है, this is our lower triangular matrix, क्योंकि ये जो प्रिंसिपल डायगोनल्स का आगे क्या है पूरा का पूरा ऊपर में 0 है. That means this is lower triangular matrix. So these are called. You see here another important property is there. Suppose A is an orthogonal matrix. Yes, A is क्या है orthogonal है. Then and also we consider lambda is an eigenvalue of this matrix A. Then 1 by lambda also will be the eigenvalues of this matrix A. Is it okay? Also will be the eigenvalues of this matrix A. Yes, so if A is a orthogonal matrix and suppose lambda is an eigenvalue of this matrix A, then A in 1 by lambda will also will be the eigenvalues of this orthogonal matrix A. Suppose 2 is a 2 is the eigenvalues of a matrix, suppose capital A, which is orthogonal, then half also will be the eigenvalues of this matrix A. So also you remember this thing. And here also you see eigenvalue of a Hermitian matrix are always real. Yes, so do you know the Hermitian matrix, guys? The Hermitian matrix is nothing, a matrix in which the transpose conjugate, yes, transpose conjugate is equal to the matrix itself. If this is happened, yes, that means you say first of all you take the conjugate of that matrix and then you transpose that one. This will be here transpose conjugate and this is we denoted by theta. And if this A theta equal to A, then we call this A matrix is a Hermitian. Or for any Hermitian matrix we can easily verify that the eigenvalues always is a real. And for idempotent matrix, yes, for idempotent matrix, eigenvalue of idempotent matrix either 0 or unity or 1. Now when a matrix is called idempotent, yes, if A square equal to A, then we call here the matrix is क्या है idempotent matrix. Yes, but in case of idempotent matrix the eigenvalues may be 0 or 1. ये दोनों में कोई भी एक होगा, ठीक है, कोई दोनों में एक होगा. So you remember these properties. So guys, you see, yeah, here is an important theorem also is there, and which is called Cayley-Hamiltonian theorem. And the statement of this Cayley-Hamiltonian theorem is there. You see, every square matrix satisfy its own characteristic equation. ठीक है, कोई भी एक स्क्वायर मैट्रिक्स ने खुद का जो कैरेक्टरिस्टिक इक्वेशन होता है वो हमेशा सेटिस्फाई करता है. ठीक है, तो देखो हम लोगों को ऑलरेडी मालूम है जो कैरेक्टरिस्टिक इक्वेशन क्या होता है. कैरेक्टरिस्टिक इक्वेशन है a माइनस लैम्डा ऑफ i इक्वल टू 0. This is the characteristic equation. Yes. So now you see this equation is nothing. This is an equation in lambda. Already all of you know this thing. Yes. So if we expand this equation or if expand this matrix, you will get a expression in lambda, and this expression is equal to 0 here. That means this is a equation in lambda. Now, and also the roots of this equation will be some lambda. Now you see the Cayley-Hamilton is said that this equation is satisfy A itself. That means if we replace lambda by this A, then also this equation will satisfy. Now you see, just you verify this thing. You see here on the left hand side, if we put here A minus if we replace if you replace lambda by I, then what happen? You see, this will be A minus of A, and A minus of A is 0 matrix, and determinant of this 0 matrix is 0. That means you get here right hand side. That means you see here in the characteristic equation, if you replace this lambda by A, then also this equation is hold. And also you see here that don't confuse here. You see this characteristic equation is nothing, is an equation in lambda, and according to our Cayley-Hamilton theorem, the lambda. So guys, don't confuse here. You see here, this is our characteristic equation, and this characteristic equation is an equation in lambda. Why? Because you see, this is an equation whose roots are lambda here. So guys, you see, if we replace this lambda by A, then also this equation or this characteristic equation is hold here. Yes, that means this matrix or square matrix, this A, is satisfy its own characteristic equation. Yes.